Now let's see how a non-terminating decimal be expressed in P by Q form. Or is it possible that a non-terminating decimal be expressed in P by Q form? That is, in a rational form such that P and Q belong to Z and Q not equal to 0. So I want to express a non-terminating and never-ending decimal number into a decimal in the P by Q form, a rational number. So let's see how we can just do that, or is it possible to do that or not. For example, I take a non-terminating decimal denoted by X for 0.3 bar. Now the bar is what we know, which we have learnt in the lower classes, to be a repeating number which is denoted so on and so forth with a bar. So bar indicates that 3 repeats till infinite times. So 0.3 bar implies this can be indirectly written as 0.33333, so on and so forth. Now let's see if this number, which is never ending or non-terminating or ever recurring decimal, which can be expressed in the rational form P by Q, with P and Q belonging to Z and Q not equal to 0. So let's see if it's possible. So X is 0.3 bar, which can be written as 0.333 and so on and so forth till infinity. Then I multiply 10 on both sides so that I get this to be X times 10 is 0.333, which is also equally multiplied with 10 on both sides. So this equation is multiplied with 10 on both sides. So X times 10 is 10X, and 0.333 so on and so forth times 10 is 3.333, because this 0 makes the decimal shift to the right and 0 vanishes when the decimal shifts to the right as 3.333, so on and so forth. So I have two equations here, equation 1 and equation 2. So I have these two equations which I'm going to take out here. So with equation 2 being 10x equals 3.333, so on and so forth, and my equation 1, which is 0.33, so on and so forth, I try to subtract the two equations so that this, on subtracting, changes the sign and I get 10x minus x, which is 9x, and 3.333, so on and so forth, minus 0.333, so on and so forth, will exactly give me 3. The subtraction will make this as 3.00 and so on and so forth, because 3 minus 0 is 3, 3 minus 3 is 0, 3 minus 3 is 0, 3 minus 3 is 0, and so on and so forth, all zeros till infinite times. Therefore, this on further simplification reduces to 9x equals 3, which by taking the constant to the right gives me x equals 3 over 9, which is 3 1s, 3 3s. Therefore, x is 1 over 3. Therefore, my x, which is 0.3 bar, can be written as 1 by 3. So I finally understand that x, which was 0.3 bar or which was 0.333, so on until infinity, can be expressed in the form P by Q, with P being 1 and Q being 3, and both P and Q belong to Z and Q not equal to 0. Therefore, it is possible that every non-terminating decimal can be expressed in the P by Q form, the rational form, with two tests. Test 1, PQ belonging to Z. Test 2, Q not equal to 0. Now let's see what if the non-terminating decimal or the recurring decimal is with two decimal places. In the previous session, we have seen a number which has one decimal place, 0.3 bar. Suppose I have the bar for 2 digits. Let's see how we can construct or how we can convert that into a rational form. Or is it possible or it is not possible for construction is what we're going to investigate in this session. For example, I take my value of x, which is 2.69 bar. Suppose my bar is for 2 digits, then the only thing I do is I just try to expand this, repeating the bar all the times. And the secret behind this is to shift this decimal not by one place but to 2 places, because it is the repeating number which is taken into account every time we try to convert the non-terminating decimal into p by q form. So I have this to be the number which repeats is after every 2 digits, therefore the decimal has to shift twice on the right, which is possible by multiplying 100 on both sides, because if I multiply 10, the digit moves only 1 unit shift to the right, but if I multiply with 100, the 2 zeros make the decimal shift 2 units to the right. And therefore, when I multiply x with 100 on both sides, I get this to be this times of 100, and which on further simplification gives 100x equals 269.69 and so on and so forth. And my original x, which is this, converts to be x equals 2.69696969. The reason behind putting the decimals same is that when we subtract, all the decimals should get vanished, and therefore in order to make the decimals equal, the only possibility is by multiplying 100 on both sides, so that here I can subtract so that all the decimal values vanish to 0. So after this, my next step is to subtract, so that 100x minus x is 99x, and 269 minus 2 is 267.69000000, and so on and so forth, is how it vanishes in the decimal part when we subtract through multiplying 100 on both sides. So I get this to be x equals 267 by 99 is how we get, and I can further simplify this to be 3 8s are 24, 3 9s are, and 3 33s. Therefore, this most simplified answer for this is 89 over 33. Therefore, my representation of 2.69 bar, which is a non-terminating decimal which repeats 696969, can be written in the rational form as 89 over 33. P and Q both belonging to integers and Q not equal to 0 is how I understand the connection of the non-terminating decimal, which is possible to be converted to P by Q form. Similarly, if I have a 3-digit repeating number, say for example I have x equals 1.413 bar, then I have the 3 digits which repeat on and on. Because there are 3 digits repeating, the concept of multiplying by 100 for 2 digits shifts to multiplying by 1000 on both sides, because 3 zeros make 3 digits shifted by the decimal to the right. This is how we understand accordingly through the number of digits which have the bar existing, the number of zeros which we multiply on both sides is how we understand the tricky concept.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.